Have you ever, gotten one of those AI reports? It's packed with facts, sure, but it just feels, I don't know, like a first draft.
Yeah, like it's missing something.
Exactly. Like
Huh.
it lacks that real synthesis, maybe, or that back and forth refinement you'd expect from an expert. And you end up feeling like, okay, I still need to do the real research myself.
Mm-hmm. It's a common problem.
It really is. You want to get truly well informed, fast, but without drowning in data or just getting some superficial summary. And, well, that's exactly why you're here, doing this deep dive with us.
We try to cut through the noise.
We do. We're your shortcut, really, pulling out the key insights so you can get properly up to speed. Today, we're tackling something pretty fascinating, a new development in AI,
Mm-hmm.
specifically how AI is learning to research and write reports. Well, a bit more like how we do it.
That's spot on. Yeah, the core topic today is something called Deep Researcher with Test Time Diffusion. It's a bit of a mouthful, so we'll call it TTDDR.
It's TTDDR.
And it's this novel framework coming out of Google Cloud AI research. The whole point is to push what large language models, LLMs, can actually do, especially when you ask them for these complex, long research reports.
And the test time bit, what's that signal?
Right, good question. That means it's not about training a whole new model from scratch. It's about how the AI dynamically refines, kind of improves its own output while it's generating the report, like right there in the moment.
Okay, interesting. So our mission for this deep dive, let's peel back the layers on this TTDDR. We need to understand how it works, why it's supposedly such a big leap forward, and maybe most importantly, what its actual impact could be for you, for anyone who needs to get smart on a topic quickly, whether you're student, working professional, or just curious.
It's like a plan.
All right, so let's set the scene. We know LLMs are powerful, incredibly so. But when you get to deep research, the really long, complex reports, what are the main hurdles, the limitations that TTDDR is trying to fix?
Yeah, that's the crucial starting point. So existing deep research agents, DR agents, they're pretty amazing in some ways, but they often just plateau, especially with these complex long-form tasks.
Plateau how?
Well, they tend to rely on maybe more generic algorithms for improvement at test time. Things you might have heard of, like chain of thought, which helps the AI think step by step.
I know that one.
Or Monte Carlo tree search, which is like exploring lots of different paths. But these methods, they often lack a genuine iterative feedback loop for the whole report.
Okay, so if I'm following, it sounds like the older systems are maybe good at finding information, but not so good at figuring out what to do with it iteratively, like how to weave it all together and refine their own writing based on what they found.
That's a great way to put it.
Is it fair to say they sort of hit an intelligence ceiling for these really complicated jobs?
Exactly. The piece that's often missing, the crucial bit, is a design that deliberately tries to copy how humans actually write and research. Most current agents, they don't really have a principled, draft, search, get feedback, revise mechanism built in. They might gather data, yes, but the way they generate the report isn't truly iterative. It's not always globally coherent, especially over a long document. And that points to a real limitation in how they handle and synthesize loads of information, particularly during a long, drawn-out research process.
Okay, let's unpack that. If the AI is falling short, how do we humans actually do it? Complex research, writing. What's that process TTDDR is trying to copy? Because honestly, my own process can feel pretty chaotic sometimes.
You and me both.
Uh-huh.
And cognitive studies back that up. They show pretty clearly that humans almost never write in a straight line, first word to last.
Definitely not.
Right. We usually sketch out some kind of high-level plan, maybe an outline. Then we draft something. Then we get into multiple rounds of revision, and this is key. During those revisions, we often realize, oh, I need more info here, or these 2 points conflict. So we go back out, we search for new articles, use search tools, gather extra stuff to refine our points or bolster arguments.
It's a loop, isn't it? Search, think, write, revise, search again.
Exactly. It's this constant iterative loop of searching, reasoning, and revising. I definitely remember some late nights doing exactly that, trying to reconcile sources for a big paper. It feels very human.
So how on earth do you translate that very human, sometimes messy loop of drafting and revising into an AI framework? That sounds like a massive programming challenge.
It does. But the researchers found this really striking similarity. They saw a parallel between that human writing pattern and something called the sampling process in diffusion model.
Diffusion models, like the ones used for generating images.
Exactly like those, but applied differently. Think of it like this. A diffusion model starts with noise, right? A fuzzy image. In this analogy, the AI generates an initial noisy report draft. It might be rough, incomplete, maybe even a bit contradictory.
Okay, like a really rough first draft.
Precisely. Then there's a denoising module. And this module, often helped by pulling in external information retrieval, refines that noisy draft into something much higher quality.
Yeah.
TDDR basically takes that whole paradigm and applies it cleverly to writing a research report.
That's actually a really cool analogy. So TTDR is meticulously modeling this human-like iterative thing. How does it actually do it? You mentioned mechanisms working together.
Yes, exactly. The framework basically hinges on two core interconnected mechanisms. The first one is report-level refinement via denoising with retrieval.
Okay.
So an LLM generates that initial noisy draft just using its internal knowledge. Think of this draft as a kind of dynamic skeleton, something that can be updated.
Nice starting point.
Then this skeleton goes through iterative refinement. That's the denoising part. But, and this is crucial at each step of denoising, it's boosted by targeted retrieval. It goes out and finds specific external information needed right then to improve the draft.
So it's not just refining based on what it already wrote, it's actively fetching new info to make it better.
Precisely. It creates this continuous feedback loop. The current draft, as it evolves, helps figure out the next search query. Then the new info that comes back from that search is used to revise the draft again. This keeps the report coherent, keeps the research on track, and helps minimize information getting lost along the way.
Okay, that covers the whole report getting better over time. What was the second mechanism?
Right, so that's the big picture refinement. But the second mechanism works alongside it, and it's called component-wise optimization via self-evolution.
Component-wise?
Yeah, so beyond refining the entire report draft, each individual piece of the process gets optimized too. Think about the steps involved. Making the initial plan, generating search questions, finding answers to those questions, even generating the final report section. Each of these components goes through its own mini improvement cycle.
How does that work?
Well, it starts by having the component produce several different versions of its output. So for instance, instead of one search query, it might generate 3 or 4 slightly different ones.
Okay, diversity.
Exactly. Then each of these variations gets evaluated by another LLM acting as a judge. This judge gives it scores like, how helpful is this query, how comprehensive, and also gives written feedback, critiques.
It's like peer review for AI components.
Sort of, yeah. Then the component revises its outputs based on that feedback. This might happen a few times in a loop. Finally, the system takes the best revised versions and merges them into one high-quality output for that step. What this does is it encourages the system to explore different angles, different bits of knowledge, and it helps prevent losing important details at each small step of the much longer research process. This ultimately provides better, richer context for that main report diffusion process we talked about first.
So wait, the really clever part here seems to be that the AI isn't just adding more facts. It's actively learning to improve its own process at every stage, using self-critique, external searching, almost like an editor guiding a writer. But the AI is being its own editor in a way.
That's a really good analogy.
So it's not just about polishing the final report at the end, but about constantly boosting the quality of every single step that gets it there, making sure the info it gathers and uses is solid and diverse right from the start.
You've absolutely nailed it. It's that complex interplay, that synergy between the denoising with retrieval for the whole report and the self-evolution for each component. That combination is critical. That's the secret sauce for getting these really high-quality research results.
That makes a lot more sense now. Okay, let's get practical. Can you walk us through how these different parts actually connect and run? What does the overall workflow look like, maybe behind the scenes, that makes this iterative refinement possible?
Sure. The TTDDR framework itself is built on a 3-stage backbone. Think of it as the underlying structure for the deep research agent. And this structure is designed specifically to overcome the limitations you see in simpler, more linear systems. Things like Hugging Face OpenDR or maybe GPT Researcher, which sometimes lose the big picture, the global context, when they're tackling a really long research task.
Okay, 3 stages. What's first?
Stage 1 is research plan generation. Pretty straightforward. You give it your query, your research question, and a dedicated LLM agent cooks up a structured research plan. It outlines the key areas the final report needs to cover. It's like the initial scaffolding.
Makes sense. Start with a plan. What's stage 2?
Stage 2 is where the iteration really happens, iterative search and synthesis. This is actually a nested loop. Inside this loop, you have stage 2A, search question generation. Here, the system formulates very specific search queries, and it does this based on the plan from stage 1, your original query, and importantly, the context from previous loops, what it's already found and written.
So it learns as it goes what to ask next.
Exactly. Then comes stage 2B, answer searching. This uses a system similar to retrieval augmented generation, RAG, you might have heard of it.
Yep, RAG.
It searches external sources, think Google search or internal databases, finds relevant documents, and then synthesizes precise answers from those documents. It's not just dumping raw text, it's extracting and summarizing the key information related to the question asked in 2A.
And this loop keeps going.
It does. It continues until the research plan is basically covered, or it hits a preset limit, maybe up to 20 search cycles or so.
Got it. Plan, then loop through search and synthesis. What's the final stage?
Stage 3 is final report generation. At this point, another LLM agent takes everything that's been gathered the plan from stage 1, and that whole series of structured question-answer pairs from stage 2 and synthesizes it all into the final comprehensive coherent report.
And where does the denoising part fit into these stages?
Good catch. It's woven in. Remember the draft report that's being iteratively refined? That current draft gets fed back into stage 2A.
Okay.
So the draft influences the next search question. And then the synthesized answer that comes out of stage 2B is used to revise and denoise the draft report. It's integrated right into that search and synthesis loop.
Okay, wow. That sounds incredibly sophisticated, genuinely innovative. But, the big question always is, does it actually work better in the real world? Why should you, our listener, really care about this framework beyond just, the cool tech?
Right, the so what question. And yes, it seems to deliver. TTDDR is really engineered for much broader use cases than older systems. You can think of it more like a research companion.
It depends.
Yeah, one capable of generating genuinely helpful and comprehensive reports for really complex questions. Across different fields, too, they mention finance, biomedical, even recreation and tech. It's aimed squarely at those tricky queries where current top LLMs might struggle if they rely only on their internal knowledge or just basic web search.
So, did they test it? How does it stack up?
They did. The research paper details rigorous evaluations against other leading systems. They compared it to OpenAI Deep Research, Perplexity Deep Research, Grok Deep Research across several different benchmarks.
Then the results.
Pretty compelling, actually. TTDDR consistently hits state-of-the-art results. For generating these long research reports, it won 69.1% of the time on one benchmark called long-form research and 74.5% on another called Deep Consult in direct head-to-head comparisons with OpenAI's system.
Wow, those are significant win rates.
They are. And it also outperformed on tasks requiring multi-step reasoning, like benchmarks called HLE Search and GAIA. Critically, across the board, the reports generated by TDDR scored higher on both helpfulness and comprehensiveness.
Okay, so this isn't just some minor tweak. It sounds like a pretty substantial leap forward in how AI can actually conduct and present research, almost like it's getting closer to a new level of understanding for these tasks.
That seems to be the implication.
Did the researchers figure out what specifically was giving it that edge? Was it the denoising or the self-evolution part?
That's right. They did ablation studies, basically, turning off different parts to see what happens. And what they found confirms the synergy idea. Just adding search tools to an LLM helps, sure, but you need the full TTDDR with both the self-evolution and the denoising with retrieval working together to get those really big gains.
So both parts are essential.
Both are crucial. And it's also pretty efficient. You get significant performance boosts for the extra processing time it takes. They found, for example, that the self-evolution part dramatically increased the complexity and richness of the search queries and the answers it generated. Meanwhile, the denoising with retrieval made sure that new information was incorporated quickly, making the queries more novel and allowing the system to use information effectively even early on in the research process. It's really how they work together.
Okay, so wrapping this up, what's the big takeaway here for you listening in? This new framework, TTDDR, it sounds like it's more than just an academic paper. It feels like a blueprint for, truly intelligent research assistants. Ones that learn and get better almost like a human expert does.
I think that's a fair way to see it. That ability to iteratively improve a draft while dynamically grabbing external info and self-optimizing every little step, it means we're getting much closer to AI that can be a genuine partner in understanding complex subjects.
Right, moving beyond just finding facts to actual synthesis and reasoned presentation. Imagine having an AI that doesn't just spit back facts, but genuinely researches, reasons, revises its own understanding, and then presents you with clear, comprehensive, helpful insights whenever you need them. It feels like the future of just being well-informed got a serious upgrade. It tackles those issues of draft quality and real depth we started with.
A potential step change.
So here's something to think about, a little provocative thought to leave you with. What kind of new questions will you start asking? What deeper understanding might you go after when you potentially have an AI research companion at your fingertips? One that can craft these perfectly denoised, deeply researched insights, mirroring the best parts of how humans research. What becomes possible then?